You know that feeling when you have an idea in your head? A story, a scene, just a single thought, and you wish you could just make it real? Well, that's not science fiction anymore. We are living through an absolutely wild revolution in AI that's turning simple words into video that looks, well, real. I mean, just look at this. This little guy isn't real. The surfboard, the waves, none of it. This entire clip was generated by an AI from that one sentence you see on the screen. It's pretty incredible, right? So the big question is, how is this even possible? It all comes down to a brand new field in artificial intelligence called text-to-video models. This is a type of generative AI, which is a fancy way of saying it creates stuff that's never existed before. These models are built to understand our language, the way we talk and write, and translate it into this super complex, moving world of video. And when I say new, I mean really new. The progress here has been just explosive. We're not talking about some slow, steady improvement over decades. The jump from weird, blurry animations to the kind of quality you just saw, that's happened in just the last few years. It's moving at a breakneck speed. But making that leap was not easy at all. See, creating a video that feels real is way, way harder than just making a single still picture. It's a whole new ballgame with a whole new set of problems that researchers have been working like crazy to solve. So what's the big deal? Why is video such a massive headache for an AI? I mean, why can an AI draw a fantastic picture of a cat, but making a video of that same cat just, walking? That's a whole different level of difficulty. Okay, so here's the breakdown. With a single image, the main challenge is something called spatial fidelity. All that means is, does it look right? Is the cat shaped like a cat? But with video, you have that, plus this other much trickier problem, temporal consistency. It's not enough for each frame to look right on its own. They all have to make sense together, over time. The shadows can't just jump around, the cat's leg has to move smoothly, everything has to be consistent from one moment to the next. And a pretty hilarious example of this is a little inside joke among researchers, the Will Smith eating spaghetti test. Now, it sounds ridiculous, but it's an amazing stress test for an AI. Think about it. You've got the physics of the noodles, the complex motion of chewing. Getting all of that to look coherent and not like a complete nightmare is a massive test of a model's understanding of that temporal consistency. All right, so we know it's really, really hard. But how are they actually pulling it off? How does an AI go from a blank screen to a finished video? Let's pop the hood and take a look at the engine that's making all of this run. The secret sauce here is a technology called a diffusion model. The best way to think about it is like a sculptor. They start with a big, messy block of stone. It's just chaos. But guided by their idea, they start chipping away, piece by piece, until a statue emerges from the noise. That's what a diffusion model does. It starts with a screen of pure digital static, and guided by the text prompt, it slowly refines that chaos, step by step, until a clear video comes into view. So here's the process in a nutshell. It all starts with pure static. Then the AI reads the prompt, let's say a cat walking. It starts to turn that static into something that looks a little bit like a cat. And then comes the crucial part. It generates the very next frame, but it makes sure it connects perfectly to the last one, creating that illusion of motion. And it just keeps doing that, over and over again, always keeping that temporal consistency in check. Okay, making a few seconds of video is one thing, but the next big frontier, the next mountain to climb, is scaling all of this up. We're talking about training these AIs on millions of longer, higher quality videos, which takes a truly mind-boggling amount of computer power and, just as important, the right kind of data to learn from. The biggest problem is that video files are just massive. Trying to train an AI on them requires an insane amount of computational horsepower. So researchers are in this constant race to build smarter, more efficient ways to do this, like a model called VCheckEct 2.0. So they can handle longer, better-looking videos without needing a supercomputer the size of a small country. Now this is where it gets really interesting. It's just like they say, garbage in, garbage out. An AI is only as good as the data it learns from. This chart here shows the aesthetic score, basically how good the videos look when an AI is trained on random public datasets versus a really well-chosen, high-quality dataset. And it's no contest. The better textbook creates a much, much better AI student. And it's not just about making things look prettier. It's about teaching the AI more complex ideas. So what you're seeing here are two frames from the same video concept. The difference between a simple static shot and one that has dynamic camera movement, all comes down to the quality of the text description that the AI learned from. And here's the key. The old way was a simple caption, a bridge over a river. That gets you a nice but kind of boring static picture. But look at the new, more detailed caption. It describes camera movement. The camera zooms out. This doesn't just teach the AI what to make, it teaches it how to film it, which is how you get those really cinematic, professional-looking shots. It's a game changer. So now that we kind of get how this stuff works, it's time to zoom out ourselves. This incredible creative explosion is happening, but it also comes with some really serious consequences and questions. We got to look at who the big players are, what the tech still can't do, and some of the ethical minefields we're all about to walk into. First off, just look at this timeline. The speed is unbelievable. Just a couple of years ago, in 2022, the first real models started showing up. By 2023, you and I could actually use one. And now, in 2024, models like OpenAI's Sora and Google's Veo are hitting quality levels that look like they came from a movie studio. We're talking major breakthroughs every few months. So here's a quick snapshot of the big players right now. You've got giants like OpenAI and Google who are just pushing the limits of realism. Then you've got pioneers like Runway who are tackling really specific, hard problems like making photorealistic humans and keeping characters looking the same from shot to shot. Everyone's kind of carving out their own niche. But let's be real for a second. This tech is not perfect. Not by a long shot. It's still incredibly expensive to run. It can totally misunderstand what you ask it to do. And it still struggles with some of the same weird problems that AI image generators have, like getting hands right or trying to render text that isn't just a garbled mess. And that, of course, brings us to the really heavy stuff. This incredible power to create video out of thin air, well, it opens a Pandora's box of ethical problems. We're talking about the potential for super convincing misinformation, creating videos of real people without their permission, and this huge ongoing debate about whether it's okay to train these AIs on copyrighted art and videos. These are massive questions with no easy answers. So, after all that, where are we? Well, we're standing right on the edge of a completely new reality for how we create things, an era where the only real limit might be your own imagination. But with all that power comes a really important choice about what we're going to do with it. And I think that's the ultimate question, isn't it? On one hand, this technology could be the great equalizer, a tool that lets anyone with a story become a filmmaker. On the other hand, it could become the most powerful tool for deception the world has ever seen. The tech is here, but which path we go down? Well, that's up to us.